Okay, so I'm going to go over some karyotypes with you first, and then I'll do the first problem of your assignment with you as well. But before we get into your assignment, I just wanted to review them a little. You would have done these in your biology class. You might have only spent a day or two looking at them, and it's mainly just so you can determine if there's a genetic condition and what the gender of the organism is. So we're going to be looking at male versus female karyotypes for humans because they should have a perfect 46 chromosomes. If you have more than that, there's some type of a genetic condition. If you have less than that, there's a genetic condition. So when we look at a karyotype, and pull this picture up here, you can see that the chromosomes are X-shaped, and this means that they have not went through a cell division yet. So they were copied, but they haven't separated. You have 22 pairs that are labeled here. These 22 pairs are going to be your autosomes, and they are arranged in order from the tallest down to the shortest here. The shorter ones have less genes on them. The longer ones have more genes on them. And then you have a 23rd pair here that is labeled as an X and a Y. Sometimes it's not labeled as X and Y. They don't label it as anything. And you're expected to be able to determine male versus female, whether it's labeled or not labeled. If you have two X's, then they should both look like this. They should both be exactly the same size. If you have a big one and a little one, that's an X and a Y. X and a Y is a guy. Two X's is a female. So this one here, everything is all paired up. I don't see any type of genetic mutations by looking at the chromosomes. Yes, this one here is a little bit squiggly, but that doesn't mean that anything is wrong with it. If we go over to this one here, so they just took all the chromosomes, they arranged them. Again, just because it's curved does not mean that there's anything wrong with it. They are all set up here, labeled from biggest to smallest. We have 22 pairs. Our sex chromosomes are over here. We have two X's. I know they're X's because they're the same size. The Y is extremely little. So this is a female. And as I look at this, I see that there are 3 chromosomes here. Your chromosomes should only be labeled in pairs. So since we have 3 there, that to me indicates that there is some type of a problem. This one is going to be on chromosome pair 21. You could count, since we can't see the numbers, we have 18, 19, 20, 21, 22. If you have 3 chromosomes on 21, which is probably the most common thing for you to see, that means that this individual is going to have Down syndrome. Okay, we could take a look at this one here. This one is more of a nice image of one instead of actually having the genes on it. You can't see any bands like you can on the other ones. Like this one, for example, you can see there's some light and dark regions. Those light and dark regions are going to indicate specific genes on those chromosomes. So here, everything is looking really good as far as our autosomes go. Your autosomes, again, are pairs 1 through 22, and they control everything that is not related to your sex. Now over here, this is where our sex chromosomes should be. We're supposed to have 2 of those. We only have 1 X. So this individual is XO. So they would have some type of a genetic condition. This is going to be a female because there is no Y. Now you might be thinking, well, is there a chance for you to have just a Y chromosome? And the answer to that is actually a no. You can't just have a Y. There are some genes on that X chromosome that both males and females need in order to survive. So just a Y isn't actually going to produce a viable baby. Let's see, moving on down to this one here is a really nice banding pattern. You can see it looks like everything is paired up here. I don't see any triplets. I don't see anything that just has 1 chromosome. Here's my sex chromosomes over here. I have a big one and a little one, so that is going to give me a male. They do have fluorescent karyotyping equipment, so if you were actually to go to a geneticist and have your karyotype read, they would probably have a picture that looks more like this, and that is just highlighting the different regions that genes are located in. This particular individual is going to be a female, and it looks like a completely normal karyotype. Here's another one. Again, autosomes all look normal, female down here. Trying to find one with the address on it. Well, I can show you the address on your assignment. All right, so if we go into yours, it's going to look like this. It says karyotype worksheet at the top. I put it into Cami, so you should be able to type directly on it. And when I was talking about address, that's going to be these letters here. So each set of chromosomes has their own address, which is identified by letters. And the letters, they go down per row, and they're more associated with size. So if there's a big size difference, you get a new letter. Okay, so that's why we have A up here. These guys are B, C. These ones are all basically the same size. They might differ by a few genes. D's are the same size. You got your E's, F's, G's, and then the sex chromosomes don't actually have one because they are separate from your autosomes. So I'm going to go to a text box here. Karyotype A is the first set of chromosomes we'll look at. Notice that the chromosomes are all paired up. How many pairs do you see? So I have 22 pairs that are labeled and one over here that's not labeled, but regardless, I still have 23. Let me see here if I can, I don't know if that's easier for you guys to see or not. 23. Looking closer, you will see that some of the pairs, that the pairs of chromosomes are paired according to certain likenesses among chromosomes. List some likenesses you see among the pairs of chromosomes. So what I see is that there is a size, similar size. They have banding patterns that are the same as well. Each karyotype chart also shows some important details about the sex of the organism. Looking at this particular karyotype, what is the sex of the organism? There's two X's here, so this particular one is a female. The chromosomes in the karyotype also show some light and dark bands. What do you think these regions of light and dark bands are? Those are going to be the genes. If you start with chromosome 1 and go until 22, you see a trend in size correlation. What is this correlation? So here's 1, and they're saying, okay, look at all the chromosomes in order with the numbers. What do you notice by the time you get to 22? They are ordered from biggest to smallest. How do you think this trend affects the number of genes present on any particular chromosome? Well, I believe that the smaller they are, the less genes they contain. And each pair of chromosomes are numbered. How many numbered pairs do I see? I don't know why I can't. There we go. There's only 22 that are numbered, okay? 1 to 22. The sex chromosomes are not numbered, but they are pair 23. What are the numbered pairs of chromosomes called? Those are your autosomes, and they control all of the genes that have nothing to do with the sex. There is a final set of paired chromosomes called the sex chromosomes. What are the possibilities for the sex chromosomes? You can either be XX, or you can be XY. You'll notice that the pairs of chromosomes are categorized in groups. These groups are lettered A to G. Can you see any reason or trends in the categorization of the chromosomes? If so, what is the trend? So like I said earlier, these letters are going to represent the address of the chromosome, and they go from size correlation. So the longer ones are paired together. If there's a big size difference, then you jump to a new address. So for this question down here, I'm going to put that there's a size difference. Size difference needs a new letter. Oh, goodness. Every karyotype is specially named. This naming system is based on three things. One, the number of chromosomes, for example, 46. Two, the set of an organism, example, sex of an organism, XX. And three, any extra chromosomes that would cause a genetic defect. And if there is, you would put a plus and what number that chromosome is on. You wouldn't just say +1 because there's an extra chromosome. You have to say the specific number. So if you have 3 on pair 18, you would put +18. If you have 3 on number 12, you would put, +12. Or maybe you just have 1 chromosome instead of 2 on 22, you'd put -22. So first we have to figure out how many chromosomes there are. So you could count to determine that. But since we have pairs for everything, and we have 23 pairs, that means that our first number is going to be a 46. 46. I don't know why it always does that. The sex of the organism. So we're going to go with XX. And the last thing is genetic defects. Now, there are no genetic defects. This is a normal one. So I am just going to put ±0 because I don't have any genetic defects at all. So you'll be going on to karyotype B here, and you're going to answer the questions. They are very similar to the ones that I have up there above. These ones here are in X's, so if you're looking at it, it's not the clearest of pictures, but you can kind of see that this shape here is an X. They're all in X's, whereas the ones up here are singular. So these ones that I had in A had already been duplicated and the chromosomes split apart. Down here, these chromosomes were replicated, but they have not yet been split in half. So whenever it's talking about, is this question here, can you tell there's a huge difference? What is it? Just say that these chromosomes have replicated, but they have not yet separated. And here's that abnormality on 21. If you don't remember what I said about chromosome 21 when you have an extra one, you could Google it, extra chromosome on 21, and it'll tell you what syndrome you're going to end up with if you have an extra one on 21. So down here, whenever you're doing your address, you're going to put how many chromosomes there are, so count them all up. It's not going to be a 46 this time. You're going to tell me the sex, we have XY, and where is that defect? So you're going to put +21 because you have 3 on 21 this time. You'll go on down, do C, and karyotype D's and E are pretty much the same. All right, guys, that is it, and that is actually your last assignment for genetics. If you can believe that, you made it through all 18 weeks and all the assignments that we had posted here. So kudos to you, great job. The rest of the week is just going to be for makeup work in case you have anything, because if you can believe it, our term is coming to an end. It's kind of sad if you think about it, isn't it? Well, it's been a pleasure having you all in class, whether it was in person or online, and I'm sure I'll see you in the future. Talk to you later.